Hi everyone, the Australian Water School welcomes you today to another highly relevant and really useful webinar on the topic of efficient model running with automation. It's sponsored today by TUFLOW and their brilliant team of Jaap, Greg, Alex and Abigail will be presenting today's webinar. We're looking forward to this. What a top topic, important topic. And there we all are, over 600 people, over 100 countries. It doesn't seem to get smaller, this webinar program. Now, let's get this together. Jaap, Greg, Alex, Abigail, tell us a sentence or two about yourself. Kick off with you, Jaap, then Greg, then Alex, then Abigail.
Yeah, thanks, Trevor. My name is Jaap van der Velde. As you can tell from my accent and my name, I'm from the Netherlands. I've got a background in computer science. I think I'm the only one on the team at TUFLOW. And as a result, I think I'm the right kind of person to be talking about automation here. I've been working with BMT for over 8 years now. Worked with all the teams, all the TUFLOW users and users of other software. Quite a bit of work in automation. So looking forward to this one.
Thanks, Jaap.
Yeah, good afternoon, everyone. My name's Greg Collecutt. I'm one of the probably slightly more long-standing members of the TUFLOW team now. I write the GPU code for TUFLOW HPC. So my background is mechanical engineering and PhD in physics, and just love writing code and solving problems, and fluid problems are some of the most difficult ones to solve. So, yeah, that's my involvement here. But, of course, the whole automation aspect is just so important for getting the most out of the computer resources that you have, meeting project deadlines, and to some extent also getting good value out of license fees. Yeah.
Yep, that sounds great. And Alex?
Everyone, it's great to be here. I'm a coastal engineer at BMT, and a lot of the modelling that we tend to do in the coastal space at BMT requires quite a lot of compute power and compute time. So we're always interested in how can we best make use of our time and resources. So automation is a topic that I'm always really interested in. So I like to get involved in not just the engineering side, but how we can optimize what we're doing. So this is an interesting topic.
Yeah, that's brilliant. And Abigail?
Hi, I'm Abigail. I'm on the TUFLOW team working on support and training. So if you've emailed support recently, you might have seen my name pop up. I originally started as a consultant at BMT. And automation appeals to me because as a modeler, I like anything that makes my modeling life easier.
Yep, that absolutely makes sense. I totally get it. A great team. Let's look at the poll. Thanks, everybody, for answering those questions. Alex, step us through this.
Yeah, thanks. Thanks for everyone for answering the webinar questions. So we'll go through them from the top. First up is what sector are you from? And there's a decent showing of people in the commercial and consulting space. And then behind that, we've got people in government, policy and planning, and then a nearly even spread between the environment field and in academia research. And then we've got a few people spread across in some of the other little sectors as well. Going down to the second question around what modeling software are you using? So the biggest percentage seems to be around TUFLOW, but then we've followed up quickly by HECRAS, and then spread across some of the flow modeling softwares like Mike and Drains, Flow2D, ICM, XP Swims. Okay, and then on the third question, so what is your experience in model running automation? We've got quite a few people. So the majority of people use batch files. So batch files to queue up your runs and kind of keep things moving. And then just behind that, we have none. So I guess people are used to this setting models off. And then we've got a small contingent of people who seem to be using more than just batch files. So we might see what that includes later on.
Yep. Thank you very much, Alex. And thanks everyone for being involved with that poll. Let's get right into this. I'm going to hand straight over to you, Jaap.
Yeah, thank you, Trevor. We already did introduction, so I'll keep this brief. This is basically the text you might have seen on the website, just discussing what the subject for today is. Hey, Greg is on here, and he was very helpful in preparation for this talk, for this webinar. So he deserves some credit, but if there's any mistakes in here, they will be mine. So take them up with me. Like was said, please, if you have any questions during the presentation, put them in chat. Feel free to ask questions that go a little bit beyond what I'm talking about. If you were expecting something more advanced, I welcome those questions as well. If you feel something is just unclear, also don't feel afraid to ask a dumb question. I'm of the school that thinks there's no such thing as a dumb question. So please do keep them coming. We'll answer them at the end, and any other questions you might have then as well. Just to give a quick overview of what I'll be talking about. I'll get a little bit into the motivation for this particular subject. It's a little bit off the beaten path, but as was indicated, I think it's an important subject and worth talking about. I'll talk a little bit why this is a webinar on automation at all, why you should even automate. I'll get into pretty deeply into the weeds of the basics of command line automation. That might be a bit of a dry section for some people. I encourage you to sit through it and see if there's anything that you didn't know, if you know a little bit already, or if it's completely new to you, just to sort of get a taste of what that's all about. I'll get a little bit into the specifics of that there, of course. And then once we've got that out of the way, I'll talk a little bit about where and how automation can make a difference. And I've split that up into 3 sections, talking about the infrastructure, network, computers, that kind of stuff, how it applies directly to your model and your data, and how it might apply to your application and your workflow. And then at the very end of it, I think once we're up there in the air with great ideas about how we could be doing everything, I'll also try to get it down to earth again and make it a little bit more real. And then at the very end, we'll have time for questions and answers. I'm aiming to take about 40 minutes, so there should be plenty of time for your questions and answers. So why a webinar on automation and why now? For me personally, that's a very easy one. My background is as a software developer. I've filled pretty much every role there is in software engineering, whether it's programming or testing or project management or architecture, design, pretty much every role you can imagine. And I've been doing the same in the field of engineering for BMT in the past 8 years. And I'm the kind of person who sees everything as a software problem. You talk to me about your problems and I'll come up with some solution that's software. And that does mean that I very often see the relationship between software engineering or IT and modelers. BMT is mostly consultants and researchers. And what comes up quite a bit is there's an awful lot of wasted potential of people and hardware and licenses. People's time gets wasted on chores that could have been automated. Hardware goes underused or not used in the most efficient ways. And there's obviously also the subject of license time. If you pay for expensive licenses, you really do want to get the most out of it. Another question that comes up quite a bit, and it's something I'll pay a little bit of attention to, is when is a problem a problem for you to solve, and when is it a problem for IT? Very often I feel there's a big gap between what people feel IT should be solving and what IT thinks people should be able to deal with. And these are separate problems. But I think as an engineer or as someone designing models or running models, you need to at least understand enough about the idea to know what you should be asking for and to tell IT staff how to do a better job. So that's part of what I'm trying to do here. It's talking about the skills you might develop, but also about how to engage with either IT staff or maybe software developers in your own company that could help you develop automation. Then there's also the elephant in the room. It's 2024 and everyone is talking about AI all day, every day. So I will mention it for sure. One impact of AI on my presentation is that I won't go into great detail in terms of providing all kinds of examples. I think the subject is too broad to make that very useful to begin with. But also, I think just by pointing out the subjects that we think are really important, that in our experience have turned out to be very important, just by pointing them out and giving you the right keywords or the right starting point to start a conversation with, I would encourage you to just go and have that conversation with an AI. AI LLMs, large language models, are great to explore, learn, get started on these kind of subjects. And they're actually quite useful across all applications of automation that we'll be discussing. I don't think AIs are the be-all, end-all, like some people like to make out. But I think across the applications we're talking about today, they're very useful. Let's see. All right. So why automate at all? There's a couple of principal motivations that I'll spend a little bit of time on. Automating model running allows you to be more efficient. It's in the title. It's the number one motivation here. It eliminates manual intervention, right? So if you automate something, once it's kicked off, from that point onwards, it just keeps going all by itself. And it optimizes the resource use of people, hardware, and licenses, like I mentioned. The automated work is generally more consistent. You minimize human error. You get the same results over and over. Mistakes don't slip into the results. You do all of the hard work and the mistake making at the start, and once things are going, things are more predictable. It's also more scalable. If you automate your work, it becomes a lot easier to do the same work on many computers across the network, or on many computers, maybe within your own office, or even on your own machine. You might be running multiple machines at this, multiple models at the same time, using your hardware more efficiently. So it's scalable in every possible way. And then finally, automating a model run allows you to be more repeatable and reproducible. Those sound similar, but repeatability is really about knowing that whenever you run it, it does the same thing again. So you know what happens is the same thing. That kind of gets back to not making mistakes. But it's also, if you need to reproduce a problem, it tends to be easier if you're doing it through an automated fashion. But also it allows you to be reproducible, which is to say, to confidently produce the same outputs over and over again. And that's relatively important, especially in some of the fields where modeling plays an important role, where clients ask for almost byte for byte identical outputs. By automating, you make that job a lot easier as well. There's some secondary advantages apart from being efficient, consistent, scalable, repeatable, and reproducible. These kind of flow from that. I think automation benefits collaboration because it makes it so that people are almost guaranteed to do work in the same predictable way. Automation is flexible and adaptable. It might not seem that way. If you fix everything in scripts, it might feel like you're actually losing some flexibility. But I think the increased flexibility lies in being able to adjust for a specific project and adapt to the circumstances for that project without having to get the entire team on board with doing things slightly differently. By fitting it in code or fitting it in scripts, it becomes easier to adapt to a specific project and to have a memory of that as well. Automation allows you to be operational 24/7. Your scripts will diligently run through the night, and if you write them well, they might even recover from some problems. They reduce uncaught errors, because the trick with automation is you can check for errors all the time, and you can check for errors you wouldn't manually check for because it's just too time intensive, but a script can do it on the fly. And as a result, you tend to catch errors more early, and you catch errors you might otherwise not even catch until it might be too late. And finally, I feel automation empowers users because it takes away some of the drudgery, some of the heavy lifting, and allows users to focus on the parts of their job that are actually quite important. So the basics of command line automation. I'll start with just the console application, because all console applications, regardless of platform or operating system, whether you're on Windows or Linux or even Mac OS, they all operate on the same principles. And it's going to get a bit technical here, a little bit dry. Bear with me, it's only 2 pages. If you're an expert, you probably already know, and it might be a little bit arcane if you're a real beginner, but I promise these things are important ideas. When you start a console application, you tend to pass through a series of arguments. And this is true, again, for any console application. So it's an important concept. If you're familiar with programming, the arguments are the parameters you pass into a function. Maybe required or optional, all based on the application's requirements. True for any console application. Any console application, when it completes, returns an integer value, an exit code, and it tells you whether the console application's completed successfully or whether there was a problem. This is one of the really basic things that I find a lot of people who might even be familiar with writing batch files don't really do anything with. In a batch file, that would be known as an error level. But in general, an exit code you get from a console application tells you something about the success of the operation. Then all console applications take their text input from what's called the standard in stream, an input-output stream. Standard in really comes down to perhaps what text you might enter, or if you're familiar with piping or redirecting files, you might pipe a file into it, and a console application might be able to operate on some text that's being offered. And a console application tends to produce text out as well. If you run a model like TUFLOW, you're familiar with this. You start the TUFLOW executable, which is a console application. It takes arguments on the command line. If it succeeds, it gets an exit code of 0. If it doesn't, it gets an exit code of 1 or other. There's no standard in really for a TUFLOW application. It just works off of files, but it does generate a lot of standard out. We're all familiar with the text scrolling by quickly, which basically amounts to the log output, but there might be other output there as well. And in a shell or in a shell script, these streams can be redirected, sent to a file, for example, or piped from one console application to another. So you could have a whole chain, a pipeline of console applications running, where one console application takes the output of another one and turns it into its own input, processes it some more, and produces more output. So these are all very important basic ideas to understand about console applications. Then, while running, of course, the console application could get additional input from input files or configuration files, and it'll create logs and output files. And of course, other I/O might be possible as well, like network messages. In the case of an application like TUFLOW, an example is TUFLOW will communicate with CodeMeter to get a license, and it does some network traffic for that. But mostly it runs off of configuration files and input files and produces logs and output files. This is generally the model for any console application, and that's important to keep in mind because anything you run on the command line interface is either a console application or some kind of built-in command of the operating system or shell, and they all work in this same basic way. Now, the most important phrase on that previous slide is all console applications, regardless of platform or operating system. So this is not a Windows-specific thing. It's not a TUFLOW-specific thing. This applies everywhere. Now, another distinction I'd like to make, which I often find is confusing to people just getting into automation, is the difference between the terminal emulator, a command line interpreter, and the actual console application. When you double-click Command Prompt or PowerShell or open it from your Windows Start menu, you're really starting a terminal emulator, which is the window, essentially, that shows you whatever terminal you're running. And then the command line interpreter, which might be command prompt. So on Windows 10, this used to be an application called the Windows Console Host, something a lot of users have never even heard of, but it is the application you're actually looking at. And what's running inside is a command prompt. On Windows 10, if you were to start PowerShell, it would also start in the Windows Console Host. But on Windows 11, the default terminal emulator has become the Windows Terminal. And typically you might run PowerShell in it, but again, you might be running command prompt in it as well. That it's important to have that distinction because the command line interpreter is something for which each instance runs as its own environment, within its own environment. It's called a shell. And you can have a shell within a shell within a shell, where the name comes from. It's sometimes even part of the name of the command line interpreter because on Linux you'll see bash. I'll get to that in a moment as well. Let's move on. I think understanding these basics is essential to create your own applications. Like once you understand how a basic console application works, you can put them together in a way that's sensible and that actually helps you build useful applications. Think about console applications like TUFLOW and try to think how to chain them together or how to make use of these different aspects that I've just talked about. TUFLOW itself has a set of specific arguments that change how it behaves on the console, and we've tried to make it specifically useful in a console environment as well for automation. So users of TUFLOW might be familiar with TUFLOW sometimes opening up a dialogue or asking a question. You can get it to stop that behavior because that's not very useful when you're automating things. And also what you're used to seeing on the screen and appearing in a window is something you can actually do something with in an automation pipeline. So keep that in mind when you're actually running TUFLOW and trying to automate running it. Also keep in mind that tools that are already existing for automation of TUFLOW already make use of this. This all applies to writing a batch file, whether you're writing a PowerShell script or even a Python script. It's not specific to batch files alone. It's universal across automation. So if you're familiar with batch files, you're basically familiar with running stuff in the command prompt. Similarly, you can write both PowerShell scripts, which have the PS1 extension, which run PowerShell commands. And PowerShell provides way more commands and more programming structure, like for loops and functions and those kinds of things, which batch files don't. And in addition to just having these text streams in and out, it has something that's called an object pipeline. That means whatever comes out of PowerShell, a good example would be if you run a directory listing in a batch file, it's just a wad of text. You can do something with it. You might be able to search through it if you're clever, but you have to parse out the text. In PowerShell, what comes out is actually a list of objects, which is something you might be familiar with if you're into Python programming. You're actually able to access specific parts of information from that. So PowerShell is almost like a programming language right on top of your operating system. Bash is quite similar in that sense. And although you can get PowerShell for Linux as well, I think users of Bash won't feel that that's too useful. Bash scripts are very mature and very good at processing text. And if you want to make a step up from there, you'll almost automatically end up using Python and Python scripts anyway. Both on Windows and on Linux, those would be more powerful. But the problem, or at least the issue with running Python, of course, means you need to have Python installed. You need to have the appropriate environment available. So it might not be the most easy step to take. However, Python, it's not just a tool. It could even be a replacement for your automation in general. First of all, Python is a console application like any other. It means you can take text in, you can stream text out, you can do all the things that console applications do. It's not as easy as it is in the other languages, in the scripting languages, to execute other commands or to do this piping and redirection of streams. And it's also, like I said, not too easy to run without any installation. You need to have Python on your system. And if you're using specific packages, you need to install those as well. But once you do have it on there, and with some basic training, all these tasks that you're used to maybe doing in batch files or PowerShell scripts can be done just as easily in Python, a lot better and often even faster. It is worth considering as long as you can ensure getting Python there. By the way, I'll just note, you can download this presentation later on as a PDF. There's a bunch of tips hidden throughout the text, which I think I won't have time to talk about all of these. Time is very limited, but these tips are worth looking at more closely. If you notice a tip on screen and you want to ask a question about it, please do later on. But they'll be hidden throughout the presentation. And like I said, maybe not Google it nowadays, but ask your ChatGPT or Perplexity or Claude or whatever flavor you like about it. There's a few more key concepts which I won't talk about in detail. I'm just mentioning these. I think these are key concepts if you want to do automation properly. Think about environment variables. They're a poor man's configuration file. Think about the concept of a working directory where you're doing your work, because it applies to everything, including your model configuration. Everything a console application does, it does in context of that. Learn about absolute and relative paths, and think about how that affects your configuration files. If you manage to make your own models self-contained and make everything relative, it becomes a lot easier to lift and shift it to some other locations. Think about the concept of network locations, referring to them directly, and specifically something called Universal Naming Convention paths, or UNC paths, which means pointing to somewhere on the network, not using drive letters on Windows, for example, but using the machine name that the resource is actually on, which allows you to then do your automation from any location on the network. And think about user context. User context is an important one, because when you're writing scripts for yourself, they might work perfectly. And then when you hand them to a colleague, they might suddenly not work. Because if your automation relies on something in the environment that's different for you, like where your files live or what your specific rights are, that can affect whether or not the script is effective. So when you're writing automation scripts, keep user context in mind. Don't write it just for yourself, but write it for whoever wants to be running it and keep their user context in mind. I'll get into some of the areas of application of automation now, starting with the infrastructure and in particular the network. So know your topology. What that means is you should have a good mental map of all of the elements of your network that are relevant to you. Locations that matter are like storage, compute, and user access locations. So storage obviously just could be databases, could be file systems, your NASs, your network drives. And user access locations are the places where people do their actual work. Now, if you're in a really simple setting, that might be very straightforward. It might just be your own desktop machine, and maybe you're running QGIS and TUFLOW and a few other applications. You're accessing everything locally from that machine. And if it's on the network, you're still opening it from there. In a slightly more complicated setups, you might have user access using something like Jupyter Hub or Jupyter Lab running on a different location. Or maybe you sign in through remote desktop to a machine elsewhere and you're accessing data directly from there. So wherever someone gets into the network to access data, those user access locations are important to consider, as well as where the storage lives and where the compute lives. Where are they physically? Are they in the same office as you are? Are they maybe in the data center? Maybe they're on a different continent altogether. And how are they connected? So what network connections exist between these resources? You don't really have to understand this at a technical level, but just try to understand it as boxes and lines. So because you need to be able to talk to these components with your IT staff and scripters, because otherwise they won't be able to really help you out. You don't really need to know exact bandwidth or protocols, but understand or ask which connections are fast and how they compare. When you know what your network topology is like, you can design your workflow accordingly. A common example I like to mention is people running a copy job from a server in Perth to copy a file from a Sydney server to another Sydney server. Now, for people that are not in Australia, you have to realize Sydney and Perth are an incredibly long distance away from each other. There's an entire continent in between them. And yet somehow this can easily happen. Someone might sign into a machine running in Perth, copying a file from one Sydney server to another, not realizing that this pulls data from A to B all the way back to A twice across the continent. It's very inefficient. In your automation, consider where the automation is running, where is it getting its data, where is it moving its data, and how can you put your automation closer to your data. And in general, put your compute near your data. Understand where to best read, write, and log your data. Where does it need to go for someone to access it when it's needed? Where is it coming from? And how is the efficiency of getting to those locations affecting how your automation runs? If you can't get it right in one go, just automate the logistics. Like if you can't run your model right next to the data because the data is on a remote network server, consider moving the data closer to the compute, performing the compute, and then moving the results to where they need to go. This is where automation can make a really big difference. Another infrastructure element that's important is storage. Again, know your storage, know where you can put storage, how much space do you typically need if you run a model, and how much is really available. Very often you're competing for storage. It makes a lot of sense to have your automation check the available space before you start a run. If you know roughly how much you need, or even just make a high estimate, and that type of storage and that amount of storage is still available. That's a good thing to check, because very often runs will fail because they run out of space, because people, they had a look before they started a large job. It looked all right. 3 people did the same thing. Now everyone's competing for the storage. And as they're running, they run out of storage, and all 3 projects get into trouble. If you automate your runs and you do some additional automation around checking whether there's enough space, checking whether the results are right, you detect problems more early and you can deal with them more quickly. Plus, you can use the automation to free up that space, either by cleaning up stuff you no longer need or moving it out of the way. Know about your storage, which storage is fast and why, what storage is backed up, and what's the cost of using the storage. All these things should affect where you're putting stuff, and you can keep stuff on expensive storage briefly, or you can move stuff out of the way of storage that's close to compute so that other people can make use of it in the same way, really streamlining the process. It's a horses for courses kind of thing. We typically talk about 3 kinds of storage. Talk about scratch storage, which is fast and disposable. It's right next to the compute. There's persistent storage, which might be your network drives or like your shared databases. They'll be available, safe, backed up, convenient access because you want to be getting data from it frequently, as opposed to archival storage, which might be your cheap, durable, low maintenance storage where you keep stuff for the long term, but it might not be directly available. Make sure you know what kinds of storage you have, how much of it there is, and how they differ, and write your automation to use them in the right way. And then standardize access. What I mean by this mostly is make it so that when you run a script on any of the compute in your network, it sees the same thing. IT might help. If you have a large organization and a Windows network, you might look at something like DFSN, but at least set standards and follow them. Setting standards is one thing, but obviously you have to follow them. And consider generating configuration from templates so that the configuration is always the same. And you can use either environment variables or some form of scripting to generate configurations that allow you to just vary those few things that need to vary, but keep everything else standardized. So you know that the process your automation goes through is the same every single time. Standards are more important to automation than they are to humans, but you can, of course, also use the automation to check if people are actually complying with those standards. If something needs to go in a certain place or needs to be cleaned up, use automation to check whether it actually happens. So you notice problems early on.
Hey, Jaap.
Yeah.
I see you've almost finished the slide. I was just wondering. I mean, you've been talking about the the accessibility between all of your data storage and the computers where you're actually running the models. Mm-hmm. Do you have any tips or tricks on how you can tell whether or not your storage setup is really not optimal in terms of it's causing you terrible slowdowns or problems? What sort of things are you looking for in terms of making sure that you've made a good choice for whereabouts you're reading and writing your data from and to with your models?
Yeah, that's a good question. I think in part that's due to knowing your network. Like if you understand the topology of your network and you realize where those locations you're writing to are physically, and where are your bandwidth restrictions, how quick is it to write to somewhere, and that's just something you can test, right? Like automation is development, and it means that once you come up with a certain choice, or you could go A or B, it's generally a good idea to test both and to see whether your assumptions are true. So I think that part of it is looking at it as development and testing your assumptions. Another part of it is really knowing that topology, knowing where these different types of storage live and how they're networked together. Again, you don't really need to worry too much about the technology of it. IT can do that for you, but have that conversation with them and have IT have a look at the scripts you're writing, because they might say, well, if you're doing this, then we need to make changes to the network, or if only you could change it to write to somewhere else that would be more efficient. This is somewhere where IT staff can help you out quite a bit. Obviously, if you're your own IT staff, it's up to you to look at these things as well. Hope that answers the question.
Thank you. Yeah, that's great.
One final thing to keep in mind with storage. Sometimes recomputing data is faster and cheaper than storing and moving it around. Keep that in mind when you're automating. Once you've automated something, it becomes a lot easier to regenerate it. If there's nothing forcing you to keep the data around, and you can just rerun your model or rerun a couple of downloads, consider that as a better alternative than just keeping everything around. I don't know about all other companies, but most companies I've worked for so far has a lot of hoarders in there. People really like to keep their data around. Once you've generated, once you ran that model successfully, you want to keep those results because you finally have them. But keep in mind that once you automate the run of a model, running it the exact same way again is something you can now do. So there's really no need very often to keep the outputs if you keep the inputs and you keep the scripting. Third part in the infrastructure would be the actual compute. Again, know your hardware, learn what matters and collect some data. Typically for modeling, the number of cores, the amount of memory, the GPU model, the GPU memory, those are metrics that matter. once you know what matters to your models, just create an Excel sheet or a SharePoint list or whatever platform you prefer using, and collect the data on the hardware you have, just so you know where you can run what optimally. And then keep an eye on whether that hardware is dedicated to your work or shared. Because if you're sharing it with someone, you might be putting too much load on it. Whereas if you know it's dedicated to your work, you can fully use it and really bend it to your will. Configure your hardware for optimal performance. Now, this is a long list. I won't go into detail into all this. Have a look at it later. But just going over them quickly. When you're counting cores on a CPU, count the physical cores. Don't count the logical ones. So that means when you have a hyper-threading CPU and you bought it as a 16-core CPU, it's quite likely that it only has 8 physical cores and it has 16 logical ones. Count the physical ones. Those matter when you're trying to measure how quickly your stuff will run. On very new Intel processors, there's P cores and E cores. Count the P cores. Those are the ones you want to be running your models on. The E cores are nice for running all the other applications in the background. Maybe some file copy tasks. And on shared environments, if you do have large GPUs, or maybe you've bought large GPUs for your servers, partition those, don't share them. Especially for TUFLOW, we make use of NVIDIA GPUs only right now. And NVIDIA hardware has a specific feature called MIG that allows you to really partition them. And partitioning means you get a dedicated piece of a GPU just to yourself, which means you're guaranteed of getting the full performance that's there, instead of sharing it with someone, whereas whoever gets to it first might be running a model quite well, and whoever gets on there next basically has to do with scraps or gets in the way of the first person. In general, it's just a rule of thumb. Ensure you have about 2 cores minimum per GPU. Only combine multiple GPUs on a single run if your size of your model requires it. Typically, if you run 2 models, one after the other on a couple of GPUs or on the GPU, it's quicker than trying to squeeze them through in parallel. And ensure you have roughly 4 to 6 times the amount of RAM memory available for the CPU compared to the RAM you need on the GPU. These are some rules of thumb, but configure your machines to comply with this. Get a little bit of extra memory or reduce the amount of work you run on it so that you don't break these rules and you'll get optimal performance. And automate the compute configuration. So automation is not just about automating the model. It can also be about automating the setup of these machines. Make sure that everything is on there. And this is something your IT can do, right? So this is, I appreciate that some of you will be doing everything yourself and maybe you're just a one-man team. Others will work for large organizations and dealing with IT is a complete hassle and maybe you don't even want to. But the principle is the same. The task of setting up an IT environment to run your scripts in is something that can be automated as well and should be. So look at ways of automating the installation of the software you need, perhaps installation of additional scripting like a Python environment, setting it up properly, getting your licensing on there, and setting it up all in a standardized way so that when you run a script on a modeling machine, everything it needs is there and it's standardized. So don't just automate the model running, automate the compute configuration as well.
Yeah, I'll just interrupt there.
Yeah, go for it.
Yeah, just again, I mean, probably there would be a lot of people out there, I think, who would not really know how to tell whether or not an application is running on a P core or an E core. And I mean, from some of your testing, there are some quite significant differences in performance there. I seem to remember you were saying it's up to like a factor of 3 or more difference in performance. Is there a simple and easy way to tell which core it ran on, or it's a simple way of ensuring it runs on a P core? I mean, I know you've talked about bit masks for setting the affinity of the application and things, but there'd be a lot of people would have no idea about how to do that.
No, that's a fair question. I guess that's kind of what the tip that's hiding there is for. I'd love to go into all those details, but we need a week instead of an hour.
Yeah. Okay. Well, I mean, if you just type into Google, how do I get it to run on a P core and not an E core? Are you going to find a sensible answer out there?
Hardly. However, in my experience. If you ask any of the large language models nowadays, you get a really good answer, surprisingly, because this is exactly the kind of things where these AIs are actually super useful. So if you go, how do I set processor affinity for a process? Even if you don't really know what that means, you could just ask it, can you please explain what setting processor affinity for a process means? And I think thanks for asking, Greg, because it's useful to point out how to use these tips. If these tips don't make sense to you, get a large language model to talk to you about them. Explain it like ELI5. Setting processor affinity for a process, because it can be done in whatever platform you use, and it's different across them. So you can do it from a batch file. It's not easy, but it can be done. PowerShell, it's fairly straightforward. It's just a standard set of commands that allows you to do exactly what you said. Set a bit mask, which basically blots out certain cores and makes it so your process will only run on certain cores. Even listing out what cores you have and whether they are P or E cores. All of that stuff is right at your fingertips when you run PowerShell. The trick is finding out what the specific syntax is. I think that's really where these large language. I guess what I'm doing is pointing out the things to focus on. I'm not telling you the details of how to do it.
And by large language model, you mean ChatGPT or Gemini or...
Exactly. ChatGPT, Gemini, Claude, Perplexity. I've used all of them in varying configurations. If you ask me for my favorite, currently it's ChatGPT with a paid model. It's really strong in actually generating code that works, quote unquote. Like obviously, the problem with a large language model is it's only useful if you understand what it's talking about, because you can get deep into the weeds of having it explain to you what it's talking about. So yes, any of the large language models, ChatGPT, Gemini, Claude, Perplexity, they're all co-pilots. They're all really capable.
Okay, thank you.
And again, that's kind of why I think this is the right time to be talking about automation, because I feel it's the kind of thing that everybody thinks would be great if they knew how to, but it's really too complicated to get into. But and AIs can't do your job for you. Don't worry too much about people telling you you'll lose your job to it, because I don't think we're anywhere close to that. But these large language models can be a really good buddy explaining these kinds of basics to you and getting you up and running with automation really quickly. I'm just here to tell you what to ask the AI about, I guess. And, selectively, these are not just random things I came up with. These are things that each and every one of these have made big differences for ourselves in trying to get our automation right. All right, so final one on cloud. Just a few remarks on that, because this is such a broad subject that deserves its own webinar. One thing about virtual desktop infrastructure, VDI, IT departments love it nowadays. It's ideal to do all your work in the cloud and to keep an eye on shared GPU resources. Very often, these environments will have one or two really big GPUs, the expensive, tens of thousands of dollar ones, serving a few dozen, maybe even the better part of 100 users with a couple of these. That's not great for modeling. For modeling, you want dedicated GPU resources. Be very wary of shared GPU resources. Another thing to talk about when you look at cloud compute, and it's not so much virtual desktop infrastructure, but trying to run many machines at the same time, look into Azure Batch and AWS Batch. They're really full-featured. They solve problems like the provisioning, which means getting VMs up and running, the scheduling, the setup of the VM, the teardown, which means getting everything off again, and access control, so getting access to all the stuff you've set up. But keep in mind, mistakes on them are costly. You can spend a lot of money by spinning up a lot of hardware you don't need, so test a lot and test small. And they do have complex APIs. So this is definitely not for everyone. The stuff I've been talking about so far, I feel it's for everyone, or everyone should find someone in their business that worries about these things. This stuff, batch services, might be so complex that you really want to steer clear of it, which kind of gets you to specialized cloud modeling platforms. If you still want to have the benefits from cloud modeling platforms, cloud model running platforms, but you feel these APIs and technologies are too complex, there are companies out there that are starting to develop modeling environments where you can run TUFLOW or other modeling model engines. We personally have some experience with Scalgo in Scandinavia and Sentient Hubs in Australia. We even have our own products on BMT Deep. These can be very domain specific, or in the example of BMT Deep, will require a lot of bespoke work. That's not a self-service type platform. And you'll find that in general, there's no easy platform where you can just go and run your models. So you're kind of stuck between either developing it yourself or happening to find what you like. Otherwise, on the cloud, just go with simple VMs. You can always sometimes you just need a fast computer to do some work. If you have all of your automation ready to go and it can run on any machine, and you can bring it with you onto the cloud, spinning up a VM and getting ready to model on it can be a really quick thing. And the cost is actually quite manageable if you're just using it for the compute. Running through some of the rest of the subjects. In the model and data space, inputs and outputs, I'm going to go through these really quickly. Have a look at those tips later on. When collecting your data, and keep in mind you don't always need all the data there. That's true for data that you bring into your organization that you're downloading. You could download it once and reuse it later, or you could just download it again. And similarly, if you already have a model and you need to run it somewhere, if your model is large and has lots of events and scenarios, you may not need all of the data. There's tools out there that allow you to selectively download these data sets, and there's tools built in to the modeling engines, at least in the case of TUFLOW, for example. It allows you to selectively copy the files you need, or to generate a list that you can then use in your own automation scripts to move the data to where you need it, but only the data you need and not everything. Like I said before, take care of logistics with your automation, move data to where it should be and where it's most optimally used. And when you do automate this kind of stuff, don't do it yourself. Don't sit there copying files one by one with simple copy commands. See what tools are available on the platform you're on and use those from your automation, like Robocopy on Windows. And there's examples for any platform. It allows you to resume interrupt copies, gets you more feedback on the results. It's generally a better idea. And apply automation to the analysis and processing. When your model run completes, you can look at the results from your automation and extract the right information and send that somewhere you need it instead of having to access the data directly. Sometimes just a small summary of the information produced by your model might be enough to tell whether it's a good result or not. Or the other way around, get an analysis environment close to where you're generating the data. Consider something like Jupyter Hub or running Jupyter Lab on model running machines yourself to get to the data immediately after it's been written and have a look at the results, or maybe even process it before moving it somewhere else. Get your model configuration right. So test your configuration before shipping a model. This is just the simplest advice, and I'm sure gets like a vigorous nodding from people in support. Test it before you ship it. TUFLOW has a T option right there. It gives you an exit code telling you whether it's good or not, and then ship it. Avoid bad configurations by generating them. Like if you have a good way of setting up a configuration, just create templates that generate them, or just generate a scaffolding so that people don't mistakes with just setting up the basics, or copy and paste an old configuration. Editing it is a lot less safe than generating a clean one using automation. And if you don't run the model where you design it, which is generally on your own computer, check that paths and other dependencies still work where you will be running it. And don't just configure the model correctly, but configure your automation. If you write some nice piece of automation and you want someone else to use it, make it so that they can configure it using just a simple configuration file. We find that people like using TUFLOW because it's so configurable. You can do the same for your automation and drive it with a configuration file, like a JSON file or a YAML file, so people don't have to go and change your batch file or change your PowerScript or change your Python. They could just change a configuration file, and if they make a mistake, the automation can catch the mistake instead of someone accidentally breaking the script in a bad way. And develop your models. Don't just edit copies of your models. This is a really big one. This deserves a webinar almost all by itself, and maybe that's a good one for the future. This is both structuring your input databases in such a way so that you can effectively and efficiently reuse them from project to project, but also versioning your configurations. If you look at a configuration, developing a model is really quite similar to developing code. And every every software developer nowadays uses Git or prefers Git for versioning. Putting your model configurations in Git gives you the same strengths that developers have enjoyed for many years already. It allows you to be safe with your changes, experiment without breaking stuff, and in addition to that, not get endless copies of your models everywhere. Really worth looking into. And then finally, application and workflow, the scheduling. Scheduling is hard, and that shows there's some good options on Linux you can look into. We've got some experience with Slurm to do this, but obviously that only works for the TUFLOW AV users. No Linux, TUFLOW HPC yet anyway. There's relatively few Windows-based solutions. We've had some success with AC Condor, and I know of some other companies that have continued to use it, and they like it for scheduling across scheduling jobs across the network. If you're only trying to do stuff locally and schedule model runs without writing the automation yourself, Trim and TUFLOW Runner are worth looking into. And TUFLOW Runner can even be used from the QGIS runner directly, but obviously that only works in your own local machines. So that tends to be useful in the development stage, but not so much for scaling up. Again, Azure, Batch, and AWS do a really good job of scheduling. They're great on a per project basis, but it's expensive. It requires a great deal of development, and it's a difficult cost trade-off. There's sadly no easy solution here yet. Some companies are developing good solutions. We're doing stuff internally as well, but whether that makes it into a product you can buy from TUFLOW, that remains to be seen. Run your model self-contained. This is an important point as well. Run the engine in a suitable mode, make sure it doesn't require user interaction because otherwise automation breaks down. Configure your own model to be self-contained. Everything within the model should sit within the few files that go with the model. And if it needs to go outside of it, have a clear and limited set of dependencies on other locations and make sure those are standardized across your network. And you can consider containerization as an option if you're on Linux. Again, right now that's specific to TUFLOW AV if you're a TUFLOW user, but obviously many other models run on Linux as well. And containerization is really nice because it makes you independent of where you're actually running the model. All it needs is the runner. Thinking about monitoring and reporting, think about writing your logs to a location where there's user access, right? If you're running your models elsewhere, the outputs may not be needed to be accessed right away, but the logs typically are. Consider writing your logs to a location where you can access them. And keep in mind that in the case of TUFLOW, the logs are actually just recordings of what the application writes to the standard out, pretty much. So you can redirect or process that stream and do something with that information as the model is running. Last slide here, and then we'll get to Q&A. Just so sort of like down to earth, keeping it real. Automation is development, and keep in mind that whatever you automate, you will end up maintaining and supporting. You're not going to need it. Keep it simple, stupid, and don't repeat yourself. Our acronyms I encourage you to look up one before you get into automation development, and not afterwards. Keep in mind that IT will impose certain restrictions and limit your rights. You can have a great idea and you got this amazing script and it works perfectly on your computer. Try to put it on a network and it stops working because there's security norms or just practical limits that make it so it doesn't work. The network connection isn't fast enough. You're just not allowed to write there. You can't get that software installed. They don't want Python on those servers. You name it. Keep that in mind. Talk to your IT staff and security staff about these restrictions and either get them to give you a little bit more leeway or work within those restrictions. And consider the handover. If you automate your model running, that's great, but can your client deal with that solution as well? Do they need to have your scripts to be able to rerun their models if that's a requirement? Or can you deliver it in a way where the automation helps you do your work effectively, but doesn't require the client to have it as well? And keep in mind as well, whose intellectual property is your solution? And are you actually allowed to give it to the client, or are you going to be running into problems when they ask for it? I think that almost covers it. Just a final remark, always prefer a good existing solution over building a perfect one. I think that's a key thing. It's development, and this is generally true. If you spend your time on building something that doesn't exist yet, that's time better spent than rebuilding one that's already there. All right, so I guess we can get into some questions and answers.
Stunning, Jaap. Fantastic. I'm going to hand over to Greg, but I think there's a stunned silence. I think, like you said, each page is another webinar. We should turn this into a short course. Anyway, over to you, Greg, to moderate the Q&A. We've only got a few minutes in the 1 hour, 1 minute left in the 1 hour. But
here
you go from there.
I didn't realize it went over.
No. The topic is so gripping.
It's
so
broad.
Important. Yeah, it's huge.
Well, I didn't help, did I, interrupting like that?
No.
That's all right.
Okay. Oh, look, we've had a few very interesting questions come in. The first one, which I thought was a fantastic question, is where did you get all your AI, all of your images from on the slide?
It's on the last slide, actually. They're all coming from Midjourney.
Midjourney. Okay.
Yeah,
there we go.
If anyone's particularly interested, feel free to email me.
Yeah, obviously with some guidance for what the image content would be. And look, a couple of things that have been coming through in the chat channel, in the question channel, is there have been a couple of requests for some examples of scripting and automation, whether they're not sure if they're specifically after a batch file example or even just how to do a simple for loop in a Windows batch file. I'm guessing, that sort of thing can be discovered fairly easily just by searching on the internet, and even the large language models can probably give a pretty sensible answer on how to script something like that.
Yeah, at the risk of sounding as a bit of a fanboy, I actually would point you to the large language models. I thought about including some examples, but the problem is, like I said, there's already batch files, PowerShell scripts, Bash, and Python. I think all of those are really good solutions depending on what your environment is. Providing, for example, for every little thing I talked about, would just blow up the size of the presentation and also make it fairly unreadable. It makes a lot more sense to come up with a question like that in the context of a large language model, explain what your environment is, and then ask that question. And you'll get really to the point and current answers, I'm convinced. I use that kind of stuff all the time. I did it writing this presentation. I think that's the right way to go.
Yep. Okay. We have also had 2 questions come in that came in by email before the presentation. So I'll just go through them very quickly. The first question was about, it's a TUFLOW specific question about when you're using SGS method C, particularly having a long pre-processing time on converting all of the elevations to SGS parameters for the cell hydraulic calculation data. So the answer to that is that the storage binary files, the XF files, which are written after the first time processing a new model, they don't actually contain. Well, some of the files do contain the raw data, but there's a final file that contains what's called a hash of all the input data, which is basically, it's a very, very long binary number that you will only get to the same number again if you have identical inputs. So if you change anything in the model, then you'll end up changing the hash calculation for all of the elevations, which then tells it that it has to recalculate all of the SGS parameters. But provided that you haven't actually made a change to the model that changes any elevations, then it will actually reuse the previously calculated curves, and the model startup time is much, much faster if you don't change any elevations. And the second question that came in that email was regarding to when you're automating a small model. So you might be doing a calibration case or searching a parameter space where you run a small model, but you might end up running it 2,000 times or 5,000 times to canvas a whole lot of possible solutions and answers. In that situation, the startup time can become quite significant. If the model solution time is quicker than the actual start time of reading all of the input data, then, by the time you run it 5,000 times, you end up spending most of your life waiting for it to do all the pre-processing rather than actually calculate the solution. So in that situation, there are a number of things that you can do to help speed up the startup time. I had it available before. Has it gone? Here we go. Okay, so the first and obvious one is to make sure that you have XF files on, which is the default. That's the binary storage files. For the inputs, avoid shape files for your GIS data. Use GeoPackage if you can. They're much, much faster to read. And again, for raster inputs, avoid reading text, ASCII format. Use TIFF format or the FLT format, but TIFFs are very, very fast because they're also just space efficient for moving the data around. Make sure your check files are off, that you're not writing check files out. And especially check files writing over a network are very slow. So just make sure that check files are off. Make sure your model is well trimmed so that it's a tight fit around the functional model, and you're not processing a whole lot of data that's outside of the area of interest. So that covers those two questions that came in on the by email earlier. And okay, we've got one more open question. Historically, I've used back files with loops to pre-process. Is this still a contemporary method, or are people using Python scripts these days, particularly in the context of ARNR 19, which is to do with the Monte Carlo or statistical method of computing different storm event intensities and durations. So how does that... are batch files still contemporary? Yeah,
they are. So they're still supported. I think it's worth investing time in learning to do it with something that's a little bit more powerful. So given that everybody nowadays is at least on Windows 10, and most of us are moving into Windows 11 over time, but on Windows 10 already, PowerShell is always available. It's something you can rely on being there. It has some of the advantages of doing stuff in Python in that, you can write your loops and you have access to a lot more functionality, which allows you to do stuff quite quickly, like, checking some files, looking at the contents of some files, checking whether the right things are in the right place, and doing a little bit more logic like you would in a Python file without having to install Python. The answer is it depends, sadly. You can still stick with batch files, but I would stimulate most people, especially people getting into it now or are still early in their careers, to look at something like PowerShell instead. And I do think that if your environment is open to it, to having Python available on every machine, doing everything entirely from within a Python script does make a lot of sense. It's less verbose. A batch file tends to have a lot of inscrutable stuff sitting there that people don't really know why it's there, but it's supposed to be there, and I just changed this one line. That's not a great way to be changing a configuration, whereas in a Python script, if you know a little bit of Python, most of it tends to actually make sense. PowerShell is the nice middle ground.
Okay, thank you very much, Jaap. That's it. We've covered off all the questions, and including the ones that got sent in by email. So I'll hand back over to you, Trevor.
That's fantastic, Jaap. Thanks, Greg. That really great wrap up there. Thanks, everybody, for attending. As a live attendee, you will receive a certificate of attendance in the next 2 business days, and it will count towards your continuing professional education. We look forward to seeing you again. We'll wrap it up there, and I just want to say thank you to the 4 content presenters, Jaap, Greg, Alex, and Abigail, and also to the brilliant team at Australian Water School, Joel leading the team there with Renee. So from me, Trevor Pillar, and all the team, so appreciate you being on board today and making this such a live and engaging webinar. Thanks once again, everybody. See you next time. Bye for now.